Okay, and let's just start. So hopefully we're in business right now.
Wow. It looks fantastic.
Okay, so my name is Jonathan and I'm IBM's head of communications for the Mayflower autonomous ship project. It's a project I've been working on for the past 2 years, and I can honestly say it's one of the most exciting things I've ever had a chance to work on in my whole life. So before we get into detail, I'd like to ask you all to do something. I'd like to ask you all to just pause for a moment and to close your eyes and to think about the ocean. Just for literally 10 seconds, close your eyes and think about the ocean. With everything that's going on in the world and everything that's stressing us out, and obviously there's a lot that is stressing us out right now in the world, you know, when you think of the ocean, what comes to mind? For most of us, the ocean is a place of peace. It's a place where we go to relax, to spend our holidays, to get away from it all, even retire to. And I think it's really important to think about that. Why is that? Why do we find peace at the ocean? And I would say that as human beings, we are inextricably linked to the ocean. And that's not surprising. If you look at this image, I think it's useful to remind ourselves that this is, after all, an ocean planet. As you can see in this photo, 70% of the Earth's surface is covered with ocean. That's 97% of the Earth's water. The ocean produces half of the air we breathe. It regulates our climate systems. It absorbs the Earth's excess heat and stores most of the Earth's carbon dioxide. The ocean's economic importance is also huge. Ocean-based transportation makes up around 90% of global trade. More than 3.5 billion people depend on the ocean for their primary source of food. Obviously in Thailand, that's a very true fact. I'm sure you appreciate that. If we look after it, the ocean economy could double in size from 1.5 trillion US dollars a day to 3 trillion in 2030. But the problem is the ocean is actually under threat, as I'm sure we all know. It is more polluted, it's less productive, it's warmer, it's higher, it's more acidic, it's stormier, it's less predictable than ever before. A couple of interesting facts. 90% of large fish and 50% of coral reefs have disappeared in the past 50 years. Obviously, that's a reality which Thai people know all too well. If we want to understand the ocean and if we want to protect the ocean, we need a new way of collecting data about it, a new, more flexible and cost-effective way of collecting data. The fact is that today, 80% of the world ocean remains unexplored. So the question is, how do we find out more in a way that doesn't cost the Earth? So that's the perfect cue for the Mayflower autonomous ship. So the Mayflower autonomous ship, as you saw in that video at the beginning, was conceived at a meeting in Plymouth in the UK in 2016. The city officials were brainstorming ideas to come up with ways to commemorate the 400th anniversary of the 1620 Mayflower. Now, I'm not sure whether you guys know British history too well or American history too well, but the 1620 Mayflower was like the iconic ship that first transported settlers and pilgrims, as they were called, to what they saw at the time as a new world, as in the United States of America as we know it today. And this ship went down as history as a ship which, you know, was a pioneering mission into the future. And the guys in the city of Plymouth a few years ago we knew they had this anniversary coming, this 400th anniversary, and they were thinking, well, what can we do to commemorate this? And they had some ideas to create a replica. And there was one guy at that meeting, a guy called Brett Fellnoth, and he's an American guy, and Brett makes submarines for a living. And he said, well, guys, why would we build another replica? There already is a replica of the Mayflower. There's one which was gifted by the United Kingdom to the USA, I think in the 1960s, which currently it sits in Massachusetts. And Brett said, look, why don't we do something which actually talks to the future of the ocean, to the future of exploration and scientific discovery? Why don't we build an autonomous Mayflower, a completely autonomous Mayflower? And yeah, that's where the idea of the Mayflower autonomous ship came from. So the goals of this mission are to build a fully autonomous, crewless, and full-size ship. I say full-size, it's 15 meters long and about 6 meters wide. So it's not huge, but it's not a small vessel. There are other autonomous vessels in the world. By comparison, this one is quite large. They also had the goal of building an AI captain. So a captain or autonomous system which draws on all the data available to think and make decisions at sea, even when there's no network available. But then they also thought, well, what's the point of building this ship? It can't just be a stunt, right? And that's where the scientific mission of the project came about. As I mentioned, Brett builds submarines in his spare time, but another thing he does, that he runs a non-for-profit ocean science organization that explores the ocean. So he and his team figured out that in building this ship, they could also build a marine exploration and discovery vessel to help gather data about the ocean and to help us to understand key threats such as pollution, marine mammal conservation, global warming. So they're the goals. And just so I can kind of spell this out for you, what they've decided to do is build a ship, the Mayflower autonomous ship, which has absolutely no people on board and is capable of making the 3,349-mile journey from Plymouth, England to Plymouth, Massachusetts, with absolutely no people on board, no captain, no crew on board whatsoever, and limited connectivity. So obviously that's quite an undertaking. And who would be so crazy to do something like this? So let me just explain who's behind it. This guy right in the middle is Brett, who I mentioned. Brett builds submarines for a living through this company called M-Subs, based in Plymouth, UK. Primare is the marine research nonprofit, who I mentioned is the official lead of this project. It's a small organization, but they're dedicated to marine science and exploration. In 2017, an IBM colleague attended a meeting where one of Brett's team was presenting the idea. And this IBM guy heard the presentation and heard the story and the vision, and basically said, if you guys want to do this, you need IBM as your partner, because we have decades of experience in pushing the frontiers of scientific exploration. We helped to put man on the moon through the Apollo missions. We can help you to do this. And that's where this whole relationship between IBM and the Mayflower autonomous ship started. The guy on the left, he's called Don Scott, is a Canadian guy. He's based in Toronto, Canada, and he's the CTO of a new startup called Marine AI, and they build and integrate autonomous systems capable of piloting ships. It's important to point out that it's not just about those organizations. As more and more companies started to hear about this vision, more and more companies wanted to get involved. They were inspired by the challenge of full autonomy at sea. They were also inspired by the scientific mission of the ship. So one by one, these other organizations started to get involved. And I think today we can confidently call this a global coalition of partners. So let's just talk a little bit about how this thing works. The Mayflower autonomous ship is essentially an edge device. So the whole reason why this is possible today is that there are small, very powerful computing devices or edge systems that are capable of running workloads on the edge of the network with very little or no connectivity. So the Mayflower autonomous ship is full of these edge devices, mostly from NVIDIA. So it uses NVIDIA Jetson Xavier devices. And these devices are powerful enough to run all of the ship's autonomous systems, navigation systems, so that even if there is no connectivity, the ship can sense, think, and make decisions at sea. When there is a SATCOM connection available, it will connect with the IBM cloud. It will upload data back to the teams on the ground. It will reveal how the AI captain is performing. If necessary, adjustments can be made and sent back to the ship so it can carry on with its journey. But it can operate completely independent of any connection available. If we dive down a little deeper into the technologies behind it, I mentioned the whole system runs on NVIDIA Jetson Xavier devices. IBM Edge Application Manager is the Edge application software that's running all of these applications. In order for the ship to sense, it uses something called IBM Maximo Visual Inspection, which is essentially a computer vision system. So it's got 6 onboard video cameras, and the Maximo system analyzes the streaming images coming in and identifies, what's another vessel, what's a piece of land, what's a piece of floating ocean debris. There is other sensory input coming in, obviously from the ship's radar, from the ship's sonar, from the ship's maps. All of the standard things that you'd expect any vessel to have are also being fed into this system. And then the system uses something called Operational Decision Manager, which is a piece of automation software from IBM. And this basically automates the decision making of the ship. It basically assesses all of that data and then comes up with ideas for what to do next. The decisions process is supported by IBM iLog Cplex Optimization Studio, and these systems have been trained on collision regulations and also safety at sea conventions, in order that the ship doesn't just make any decision, it makes a lawful decision according to maritime law. And then finally, before the ship executes that decision, everything is checked by a special safety manager, which runs on Red Hat Enterprise Linux. So that's the AI captain system broken down into pieces. And once it's made a decision, it will send a command through to the ship's motor, rudder, and the ship will proceed with its journey in order to avoid any ocean hazards that it comes across. There's also things going on in the cloud. As I mentioned, data is being stored there. The performance data of the performance data of the ship is being analyzed by IBM Watson Studio. We also have something called Industry Acoustic Insights, which is a piece of software which is essentially listening to the noises coming from the electric motor, just to make sure that everything is humming and going according to plan, and so that there are no strange sounds which could suggest an engine failure or a motor failure coming up. Yep. There we go. So as I mentioned, the ship is not just any old ship, it's a scientific research vessel. IBM is also involved in the scientific mission for the Mayflower autonomous ship, working closely with Primare. The beauty of an autonomous ship is that there's no provision for human beings. There's no cooking facilities, sleeping quarters, no safety facilities for humans, no storage of food, nothing. So the ship can be dedicated to a mission. All of that spare capacity, which would normally be taken up by humans, in this case is being given over to the scientific mission. So there are actually there's actually capacity for 700 kilos of scientific equipment, and it's going to be packed full of scientific equipment like water and air samplers, sonar, depth sensors, nutrient sensors, listening devices, all kind of manner of things to enable scientists to actually gather data from the ship and draw insight about the ocean. And obviously that's not a small feat if you think about it, right? There are no people on board, so how do you do science on a ship? There's no hands, there's no arms, there's no nets, there's no test tubes, there's nothing like that. It's completely autonomous. So the guys behind this have had to completely re-engineer scientific experiments in order to gather the data that they need. Let me give you an example and let you into a little secret. Our ship has a tongue, and we heard a few minutes ago from Cristiano from the Zurich Research Lab, which is one of IBM's main research labs based in Europe. That team is working on a very, very special piece of technology called hypertaste. It's called hypertaste because it works a bit like a tongue. It's got an array of sensors, actually about 50 of them. And these sensors are able to kind of taste the ocean in order to make a chemical analysis. And you can see some of the outputs from the hypertaste device on the right-hand side. So they've completely re-engineered this device in order to make it autonomous. It literally, this little device on the top left, the little kind of white device on the top left, sits in the water chamber. It's got a constant flow of water going through it, and the device is constantly tasting the water in order to make a chemical analysis of the water. It's particularly useful for measuring ocean acidification and the impact of global warming on the ocean. Another great example is acoustics. Because the ship is almost silent, depending on the situation it's in, it's perfect for monitoring marine life. And you can see that it attracts, there's a photo of it from a couple of weeks ago, it attracts quite a bit of attention from the local marine mammal population. Here is a dolphin which came to visit the vessel not long ago. And so what we're doing is we're using an acoustic sensor, an acoustic array like the one you see on the left, in order to listen to the sounds of marine mammals, in particular whales. And the ship is going to be utilize a special piece of artificial intelligence that is able to distinguish one whale from another, one whale pod from another, and understand, what species of whales the ship is in the vicinity of. And obviously, this kind of research can really help us to understand the distribution of whales in very remote places, like the North Atlantic, for example. And obviously, the vision isn't that there's going to be one of these vessels, which is going to kind of perform all the scientific research that the world needs. This is very much experiment, and it's designed to open the doors on a new era of marine research, where there'll be literally thousands of these things, large ones, small ones, kind of drone type devices, that carry scientific equipment and help scientists to gather the data they need to better understand the ocean. So where are we now with this project? I'll give you a very brief overview of the timeline. As I mentioned, it was conceived back in Plymouth in 2016. IBM started work on it in 2017. The ship's hulls were constructed in Poland back in the spring of 2020. The ship was officially launched into the water on September the 16th, 2020. Right now, we're in this red section down at the bottom, which is the sea trials of the autonomous system. So this ship right now is in the water in Plymouth. It goes out every day, and there's a team that accompany it, and they test it. They see how it performs. Every day, they take it further and further and further. And what they're doing now is they're building up their confidence in the system, making sure that anything which is going to break breaks now rather than in the middle of the Atlantic. And they are readying this vessel in time for the Transatlantic Voyage, which will take place around the mid-May timeframe. That's what we're looking at. So Yeah, its first big voyage is the kind of the ultimate test, and it's the test that it was designed to do. But obviously, the ship has been built for the future. It's going to have a whole life ahead of it beyond the transatlantic voyage, and will go on to do many amazing things, collecting data in different parts of the world, and hopefully will spawn lots of children and smaller systems and bigger ones. And we very much hope it's the start of a whole new world of autonomous vessels. So what we can do now, I can see we've got a question coming up, which is fantastic. I'm through the bulk of my presentation, but what I can do is I can play a silent film, and you can see the ship, some recent images of the ship from a little bit earlier this year during its sea trials, and we can perhaps take the questions and talk over the video. Is that okay? Are you good with that?
Yes.
Okay.
Yeah. But
all right, that and yeah, we can talk. So I think we got at least one question. Let me just have a look. Oh, it's come through in Thai. So do you want to help with the questions?
I think that question belongs to the previous section about the AI build AI.
Okay.
Yeah.
So do you have any questions for me, please, or any of the audience? I'd be very happy.
No, we have not question at this moment.
Okay, no problem. So we're very happy to, we can play this a little bit and I can maybe describe it to you. So this is the ship in Turnchapel Wharf, which is the home of the ship in Plymouth, UK. These guys behind in the small rib, they are taking it out. We have to be very careful with the ship inside the harbour area, because it's an autonomous vessel, and it's the local maritime authorities carefully control what we do. Once we take it out a little bit further, it can go a little bit faster and start to kind of really motor. And this, you can see, the ship really, really just wants to go and wants its freedom. And from here we go. You can see the tether has been removed here, and the ship is really motoring. It goes about 8 to 10 knots, so it's relatively fast. And yeah, as you can see, she performs pretty well in the water. It has this very aerodynamic, low-lying form, which gives increased stability. And it cuts through the water very nicely. It's a trimaran ship. As you can see, it's got three hulls, again, which is designed to give it increased stability. It's made from composite aluminium, which is designed to be robust, but also cost effective. Materials for the ship have cost about $1 million for the materials themselves. And then obviously you have a huge amount of equipment inside the ship, and you also have the time and expertise of a lot of people from the global team around the world, which has been involved in building this ship over the past couple of years. So yeah, this is, as you can see, performing really well. Sea trials are going great. We're pretty confident that the ship will be ready to perform the transatlantic voyage in around the middle of May.
Jonathan, we have a few questions. The one question is he asking about the energy that this ship uses. What kind of the energy?
Yeah, that's a really good question. So as you can see, it does have solar panels on top. It's going to have more solar panels. So the actual wings, the two wings, will also be covered with solar panels, and that will happen before the transatlantic voyage to give it a greater input of energy, renewable energy. So if the ship was to just travel around the kind of coastal region in a kind of low stress situation, it could operate perfectly well with just the solar energy coming from the solar panels. However, as this ship is designed to cross the Atlantic, it's also been given a a backup generator, a diesel backup generator, which basically means in the middle of the Atlantic, if solar levels are low, the generator will turn on and recharge the battery so that it can continue. So it uses an electric motor, and yeah, it has it relies primarily on solar, but has a diesel generator as backup.
Okay, so we have another question. How fast this ship?
Yeah,
the speed. Yep.
So it goes about 8 to 10 knots, which is, you know, not the fastest ship in the world, but it's not slow. One point is that, you know, if you take humans off a ship, it doesn't need to go very fast, right? Because there's no rush. It can take all the time in the world, especially if it's a data collection vessel. It can literally just potter around collecting data at whatever speed required. Having humans on a ship puts a lot of pressure on a vessel. It basically means, you know, a large part of every vessel is dedicated to keeping those humans safe and keeping them fed, giving them somewhere to sleep, and, you know, and getting them to their destination as quickly as possible. If you take the humans off the vessel, all of that pressure is gone, right? So, which means that that autonomous vessels don't need to go very fast. That's the whole point. But yeah.
We have another question. The question is, if Thailand would like to do the same thing or the similar with this vessel, we can replicate this solution?
Yeah, that's a very good question. So as I mentioned, this project is not designed to be, you know, to be focused only on one vessel. So the autonomous system behind this, the AI Captain, is a piece of software which can be actually implemented on any vessel. So it's designed to be a transferable piece of technology which can be implemented on any vessel. It can also be implemented on vessels with humans. So the idea is not only to kind of kick out the humans from the ocean, but also to augment their capabilities, to keep them safe, so that if you have a crewed ship, a ship with humans on it, the AI Captain can work with them, can identify hazards, can make suggestions for what to do next. So it can almost work like a co-pilot on a commercial vessel, as well as working independently in certain applications, such as marine science. I think it's a very good application. Surveying the seabed in the oil and gas industry or the telco industry, defense, Coast Guard, I think are great applications for autonomous systems where you may see completely autonomous vessels. But it's not about removing humans from the ocean. Essentially, it's about keeping them safe and extending their capabilities.
Yeah, okay. Another question. How does this ship make decision in dilemma in case of accident or emergency?
Yeah, so I mentioned before, it's got everything it needs on this vessel in order to sense, think, and make decisions itself in the middle of the ocean, even if there's no connectivity and there are no, you know, there's no none of the human crew providing support. So it has been designed with what we'd call level 5 autonomy. That's full autonomy. And how does that work? Well, it uses all the same sensory inputs that any normal ship would use, right? So it uses sonar, radar, AIS. It uses you know, a visual identification system in this case in the form of cameras. And then it uses like an automation system based on a special piece of software from IBM in order to think through the possibilities of what to do and actually to check all those against a set of rules called COL-regs, collision regulations, which the system has been taught. So the system has been taught or programmed to understand COL-regs so that it will make not just any decision for how to avoid a hazard or an obstacle, but a legal and lawful one based on maritime law and maritime conventions. I hope that helps.
Okay, sure. Another question. How this AI ship could tolerate on every sea state along this journey?
Once again?
How this ship could tolerate on every sea state along this journey?
Sea state. That's a good question. So yeah, you're right. This is not the Titanic, and even if it was the Titanic, then as we all know, even ocean liners are not completely safe from ocean conditions. So one very important point that I didn't mention, which I should, is that the ship is working very closely with the weather company, which is, you probably know it's an IBM company that provides weather forecasting services. So we will choose our window for the transatlantic voyage very, very carefully. So based on the input from the weather company, which comes through to the control room of the ship, also it goes directly through to the ship's AI captain. It has the ability to receive weather forecasts and updates directly onto the ship. Between the ship's AI captain and the ship's human crew, they will make the optimum decision for when to launch it. And the ship is also capable of changing its course mid voyage in order to avoid a weather front, a storm on the horizon. So it's smart enough to actually choose a new course to keep safe and to make sure that it doesn't run into any storms.
Okay, one last question that how this ship work during the offline?
Yep. So we anticipate that there will be lots of periods when the ship is completely offline. And that is why I mentioned the ship leverages what's called edge computing architectures in order to process everything it needs to process locally on the ship. So it runs on a series of edge devices, most of them from our partner NVIDIA. And even when there's no connectivity in the middle of the ocean, it can make those decisions and use all of the capabilities which I've described. All of the sensory capabilities, the decision-making capabilities can be performed with no network connection, thanks to edge computing architectures.
Okay, thank you. That is very clear. All right, so we still have a few questions, but because of the time that we have to close the section. It's a very good section, Jonathan. I hope that we can see this ship sailing in the sea and got a very good information that help our Earth.
Yeah, I very much hope so too. And obviously, if any of your audience are in the UK and fancy a trip down to Plymouth, you're more than welcome to come see it. It will spend the second half of this year along the northeast coast of the USA, but we'll be back sometime at the end of the year or beginning of next year, and we'd be very happy to have your visit. So thank you so much for the opportunity to tell you about the Mayflower autonomous ship, and yeah, do get in touch if you've got any ideas or suggestions or questions.
Sure. Yeah. Thank you very much, Jonathan.